Hello, and welcome to Tech with Shaping Pixel. This time we are bringing you free certification crash course. The AWS Certified CloudOps Engineer Associate Certification Exam, also known as SOA-C03, is designed for cloud operations engineers with at least 1 year of experience in deployment management, troubleshooting, networking, and security on Amazon Web Services. If you're not already subscribed, please subscribe to our YouTube channel. Thorough preparation will help you succeed and earn your AWS Certified CloudOps Engineer Associate credential. Review the official AWS exam guide for detailed task statements and domain weightings. This exam lasts 130 minutes and features 65 multiple choice or multiple response questions. Only 50 questions count toward your score, while 15 are unscored and used for evaluation. There is no penalty for guessing, so always answer every question. The passing score is 720 out of 1,000. The exam covers 5 domains: monitoring, logging, analysis, remediation, and performance optimization, reliability and business continuity, deployment, provisioning, and automation, security and compliance, and networking and content delivery. Each domain tests your skills in areas like configuring metrics with Amazon CloudWatch, implementing backup strategies with AWS Backup, automating deployments using CloudFormation and the AWS Cloud Development Kit, managing security with AWS Identity and Access Management, and optimizing networking with Amazon CloudFront and Route 53. Monitoring and reporting. Amazon CloudWatch is a global monitoring service designed to give you deep visibility into the health and performance of your applications and infrastructure. It collects and presents operational data, helping you minimize incidents and optimize your environment. CloudWatch offers a suite of powerful features. With CloudWatch dashboards, you can build custom visualizations of metrics and alarms from resources across multiple regions. CloudWatch metrics track key data points like disk reads or number of objects, and support anomaly detection using machine learning to spot unusual activity. CloudWatch alarms let you automate actions or send notifications when thresholds are crossed, integrating seamlessly with dashboards for real-time awareness. Dashboards are fully customizable, allowing you to display exactly the data you need for specific projects, customers, or regions. Metrics can be standard or custom, and detailed monitoring is available for deeper insights, with data collected as frequently as every minute. Alarms can trigger automated responses, such as scaling resources or sending alerts. CloudWatch Event Bridge connects your applications to AWS services, enabling real-time, event-driven architectures by routing events to targets like Lambda or SQS. CloudWatch Logs centralize log data from AWS services and your applications. With Log Insights, Container Insights, and Lambda Insights, you can analyze and visualize logs, gaining actionable information to troubleshoot and optimize your systems. CloudWatch dashboards in Amazon Web Services or AWS make it easy to visualize your data without digging into each service. With dashboards, you can quickly see key information and make decisions about your workloads and processes, all from a single customizable view. Dashboards are built from widgets, which include line charts, stacked area charts, number widgets, bar charts, pie charts, text widgets, log tables, and alarm statuses. You can even run queries within widgets for detailed insights. CloudWatch also offers automatic dashboards for services like EC2, giving you instant visibility into important metrics. A standout feature is the ability to perform math on metrics and aggregate data across sources, such as monitoring CPU load across an entire auto-scaling group. You can create dashboards visually using the drag-and-drop editor or programmatically with JSON code, even integrating them into CloudFormation templates. The editor lets you arrange and resize widgets for a tailored experience, while code-based dashboards offer flexibility for automation. Dashboards can be shared across accounts and regions, with options for public or restricted access. Best practices include using large graphs for key metrics, annotating graphs, and providing clear descriptions so everyone understands the data at a glance. Amazon CloudWatch Anomaly Detection, introduced by Amazon Web Services in 2019, uses machine learning to automate the creation and maintenance of CloudWatch alarms. This reduces manual intervention and makes monitoring more effective and efficient. Machine learning models in CloudWatch anomaly detection learn what is normal and abnormal for your chosen metrics by analyzing historical data. Unlike traditional static thresholds, these models adapt over time, refining their understanding as more data is collected. When enabled, CloudWatch anomaly detection creates a confidence band of expected values for each metric. If the metric's value falls outside this band, an alarm is triggered. The model adjusts for hourly, daily, or weekly trends and updates every 5 minutes. You can fine-tune the anomaly detection threshold and use any standard or custom metric with a repeatable pattern. The service supports configuration through the AWS Management Console, AWS Command Line Interface, and AWS Software Development Kits. The model's accuracy depends on the quality and quantity of historical data. Exclude abnormal periods from training data for best results. Quote, "For the best result, at least 3 days of data is recommended," said Stephen Cole. CloudWatch anomaly detection is a powerful adaptive tool for monitoring, but it is not a silver bullet. Use it alongside other alarms for comprehensive coverage. When building systems on Amazon Web Services, or AWS, you might start with monolithic architectures. These are tightly connected and hard to scale. Microservices improve things, but still require services to know about each other. Enter event-based architecture. Here, services react to events, not direct calls. Amazon Event Bridge is AWS's event coordinator. It collects information from AWS services, external software as a service providers, and your own applications, then routes events to where they are needed. Events in EventBridge are structured as JSON strings. Each event includes details like version, unique ID, source, AWS account, timestamp, region, resources involved, and a details section with the event's content. Over 90 AWS services can generate these events. Events land on an event bus. Every AWS account has a default one, but you can create custom ones. Rules filter events and decide where they go. You can even schedule rules or send events across accounts. Targets are where the action happens. They include Lambda functions, EC2 instances, and more. EventBridge also integrates with over 30 software as a service providers, making it a powerful tool for building flexible, scalable systems. Amazon EventBridge offers a powerful feature, event archiving. With EventBridge Archives, you can store events for as long as you set the retention period, or even indefinitely. Since events are text-based, storage is efficient and cost-effective. Archiving events is essential for disaster recovery. If your database is ever corrupted or deleted, archived events let you reconstruct its exact state. Replaying events archived is also useful when updating your app or adding new features, helping you extract new insights from old data. EventBridge includes a schema registry, which describes the structure of events. Every AWS service integrated with EventBridge has pre-built schemas, making development easier. You can also discover schemas from software as a service events or create your own custom schemas from JSON. Developers can generate code bindings for Java, Python, and TypeScript. These bindings help Visual Studio validate variables and expose attributes, speeding up development for both AWS and custom schemas. While Amazon's Simple Notification Service is simple and highly scalable, EventBridge offers advanced routing and SaaS integration. Compared to Kinesis, EventBridge provides greater flexibility, especially for SaaS provider events. EventBridge also integrates with over 30 software as a service providers, making it a powerful tool for building flexible, scalable systems. AWS CloudTrail is a service designed to record and track events in your AWS account. It captures both application programming interface, or API requests, and non-API actions, whether they come from users, the AWS Management Console, or other AWS services. CloudTrail organizes events into 3 categories: management events, which track control plane operations, like creating users or databases; data events, which log resource-level actions, such as Amazon S3 Object Access; and insight events, which highlight unusual activity to help identify potential issues. To store and analyze events beyond the default 90-day event history, you can set up CloudTrail trails. There are 3 types: all region trails, which cover every region in your account; single region trails, which focus on one region; and AWS organization trails, which capture events across all accounts in your AWS organization. CloudTrail Lake lets you store, review, and query events for up to 7 years. You can filter which events to keep and use structured query language, or SQL, to analyze data, making it easier to troubleshoot incidents and security threats. CloudTrail Lake also collects logs from AWS Config and external sources, including your own data center. Integration with partners like CrowdStrike and GitHub allows seamless data capture through CloudTrail channels, enhancing your visibility and security. AWS CloudTrail is a powerful service that records activity across your Amazon Web Services environment. Whether you set up trails for a single region, all regions, or your entire AWS organization, CloudTrail captures a comprehensive log of events, giving your business a clear view of what is happening in your cloud infrastructure. One of the main benefits of CloudTrail is enhanced security. By tracking every API call, your security teams can quickly identify suspicious events, such as unsuccessful sign-in attempts or unauthorized actions. This visibility allows you to investigate incidents, determine who initiated them, and implement preventative measures. With CloudTrail, you gain a deeper understanding of your environment, helping you spot weaknesses and reinforce your security boundaries. CloudTrail makes it easy to consolidate activity records from multiple regions into a single Amazon Simple Storage Service bucket. This single pane of glass approach simplifies analysis and auditing. CloudTrail Insights, a feature you can enable, automatically detects unusual behavior in write API actions, alerting you to potential threats and providing additional metadata for investigation. CloudTrail's detailed logs support governance and regulatory compliance. By maintaining a recorded audit of actions and configuration changes across accounts and regions, your organization can meet audit requirements and ensure operational best practices are followed. To set up and manage AWS CloudTrail, you need the right permissions. Without them, you will not be able to create or configure trails. If you lack access, contact your AWS administrator or security team. AWS offers 3 managed policies for CloudTrail. The CloudTrail's service role policy is for the service-linked role and cannot be attached to users or groups. The AWS CloudTrail Full Access policy lets you configure CloudTrail and includes permissions for related services like Amazon Simple Notification Service, Amazon S3, Amazon CloudWatch Logs, and AWS Key Management Service. This is because CloudTrail often integrates with these services for log storage, encryption, and notifications. If you let CloudTrail create resources like S3 buckets or SNS topics, it automatically applies the necessary permissions. For example, CloudTrail can write logs to the S3 bucket it creates. However, if you use existing resources, you must manually add the required permissions to ensure CloudTrail works correctly. The AWS CloudTrail read-only access policy only allows you to view trail settings, list trails, and look up events from the last 90 days. It does not permit creating or modifying trails. AWS CloudTrail trails are essential for capturing, tracking, and retaining events across your AWS accounts. Without trails, you can only view events in the CloudTrail dashboard for up to 90 days. Trails send captured events to log files, typically stored in Amazon Simple Storage Service, or Amazon S3, or to CloudTrail Lake for longer retention and advanced querying. CloudTrail log files are written in JavaScript Object Notation, or JSON, and can contain multiple events. Each event records details like the action requested, who made the request, when it happened, and which AWS service was involved. For example, the user identity field shows who performed the action, while event time records the timestamp. The event source reveals the AWS service, such as signin.amazonaws.com for console logins. Other important fields include source IP address, which captures the user's IP address, and user agent, which identifies the browser or tool used. The response elements field shows if the request succeeded. Additional event data can reveal if multi-factor authentication, or MFA, was used. Each event also has a unique event ID and indicates if it was read-only. CloudTrail delivers logs to S3 using a structured folder hierarchy: bucket name, prefix, AWS logs, account ID, CloudTrail, region, year, month, and day. This makes navigation and management straightforward. CloudTrail can aggregate logs from multiple AWS accounts into a single S3 bucket, simplifying centralized log management for organizations.
AWS CloudTrail and Amazon CloudWatch work together to enhance your security monitoring by providing deep visibility into your infrastructure. By integrating CloudTrail logs with CloudWatch, you can quickly identify risks and anomalies across your AWS environment. To send CloudTrail event logs to CloudWatch, you must enable this option during trail creation or by editing an existing trail. You can choose an existing or new log group and assign a role for CloudTrail to publish logs. CloudWatch enables robust security monitoring of CloudTrail logs. For example, you can receive alerts when API calls modify security groups or network access control lists in your virtual private cloud, or when changes occur in identity and access management policies. Custom metric filters let you search for specific terms in your logs, such as unsuccessful console login attempts. By setting thresholds, you can trigger automatic notifications for suspicious activity, helping you respond quickly to potential threats. Contributor insights visualize top contributors to specific events, like changes in your virtual private cloud. By creating rules, you can pinpoint users or IP addresses responsible for key activities, making it easier to spot security issues. CloudWatch Log Insights uses a query language to analyze CloudTrail logs. With sample queries, you can quickly extract valuable information, visualize trends, and export results for further analysis, helping you proactively detect and resolve issues.
Managing a handful of machines is simple, but as your fleet grows into the hundreds or thousands, maintaining consistency becomes a real challenge. That is where automation in AWS Config come in. AWS Config is a service designed to automatically discover your Amazon Web Services resources, providing a complete inventory and tracking configuration changes over time. This visibility is crucial for operational excellence and quick remediation when things drift from your desired state. By default, AWS Config is disabled when you create a new account. To get started, you need to enable the AWS Config Recorder. This module tracks changes in your resource configurations and records them as configuration items. The AWS Config Recorder operates within a specific region and can monitor all current and future resources or just selected types. It even supports global resources like AWS Identity and Access Management users and roles. Remember, you must define a role to allow AWS Config to interact with your resources. AWS Config typically delivers its records to an Amazon Simple Storage Service bucket. You can also send detailed change notifications to Amazon Simple Notification Service or Amazon Event Bridge. Data is retained for 7 years by default. Once enabled, AWS Config examines each resource, creating configuration items, including one for the recorder itself. AWS Config brings automation, visibility, and consistency to your cloud environment. When you set up AWS Config, the first thing delivered to your Amazon Simple Storage Service, or S3, bucket is a configuration item for each resource. Each configuration item includes metadata, attributes, relationships, and the current configuration. Metadata covers details like version ID and capture time. Attributes include the resource ID, creation time, Amazon Resource Name or ARN, and tags. Relationships show how resources connect, such as an Elastic Block Store or EBS volume attached to an Elastic Compute Cloud or EC2 instance. The current configuration details the resource's present state. AWS Config delivers two main types of files to your S3 bucket: configuration history and configuration snapshots. Configuration history is a timeline of configuration items for a specific resource, showing how it changed over time. These files are delivered every 6 hours. Configuration snapshots, on the other hand, capture the state of all resources at a single point in time. Snapshots can be generated manually or on a schedule, such as every hour or every day. Both histories and snapshots are in JSON format and stored in separate folders within your S3 bucket. Aggregators in AWS Config consolidate configuration and compliance data from multiple AWS accounts and regions. This means you can view all your configuration items and compliance results in one place, making it easier to manage resources across your organization. Aggregators provide a unified view for better visibility and control. AWS Config Rules help you define the desired configuration state for your AWS resources. AWS Config continuously evaluates your resources and marks them as compliant or non-compliant based on the rules you set. AWS offers over 320 managed rules covering more than 55 AWS services. These rules are ready to use or customize. For example, the EIP attached rule checks if elastic IP addresses are attached to EC2 instances, while EC2 volume in use check ensures EBS volumes are in use. The restricted SSH rule helps enforce security by limiting SSH access. Custom roles. If you need more flexibility, you can create custom roles using AWS Lambda. Associate your role with a Lambda function to define your own compliance logic. The AWS Config Rule Development Kit, or RDK, simplifies this process for those comfortable with the AWS command line interface. CloudFormation Guard is an open-source policy-as-code tool. It uses a domain-specific language to define rules that validate CloudFormation templates, Terraform files, and Kubernetes configurations, ensuring compliance before deployment. You can choose proactive or detective evaluation modes and set triggers based on configuration changes or specific time intervals. Some rules require parameters like max access key age. Tags help organize and group resources as your AWS environment grows. AWS Config gives you visibility into your cloud resources by tracking their configurations and evaluating them against defined rules. Compliance in AWS Config means a resource follows all applicable rules. If it fails even one, it is marked non-compliant. Sometimes, AWS Config cannot determine compliance, resulting in an insufficient data status, which can happen if a rule has never been evaluated or if evaluation results are missing. When resources are non-compliant, AWS Config does not block their creation, but highlights the issue for remediation. Remediation can be manual or automatic. Automatic remediation uses AWS Systems Manager automation documents to trigger corrective actions as soon as non-compliance is detected. If the issue persists, you can set up retries and specify wait times between attempts. Hundreds of predefined remediation actions are available, and you can also use Systems Manager Change Manager to schedule changes or require approvals. A conformance pack is a collection of AWS config rules and remediation actions bundled together. You can deploy these packs across accounts, regions, or organizations using YAML documents. AWS provides templates, or you can create custom packs tailored to your needs. Conformance packs offer a flexible compliance framework, but are not designed to guarantee adherence to specific governance standards. They serve as a strong starting point for implementing best practices. Logging is often overlooked until a problem strikes, but its value to infrastructure cannot be overstated. Many organizations only realize its importance after a security breach or incident has already occurred. Logs are generated by services and applications, capturing extensive information and storing it for future analysis. Some logs can even be monitored in real time, enabling automatic responses based on their contents. From an auditing perspective, logs are invaluable. They often include metadata like date stamps, source IP addresses, and usernames. For example, CloudTrail logs help organizations meet compliance certifications by providing evidence of traceable and auditable actions. When incidents happen, resolving them quickly is crucial. Logs provide insight into what occurred before, during, and after an event, helping teams pinpoint the source and reduce resolution time. This leads to a better customer experience and can even prevent issues from escalating in the first place. By consistently logging activity across applications, networks, and cloud infrastructure, organizations can establish performance baselines. Monitoring logs with thresholds and alerts allows for early detection of threats and anomalies, giving operational teams the information they need when it matters most. Amazon CloudWatch is a monitoring service for your AWS resources, but it is also a powerful tool for collecting and analyzing logs from your applications and AWS services. With CloudWatch logs, you can monitor log streams in real time and set up metric filters to alert you to specific events. The unified CloudWatch agent is essential for collecting logs and additional metrics from Amazon Elastic Compute Cloud, or EC2, instances, as well as on-premises servers running Linux or Windows. To set up the agent, you need to create roles with the right permissions, allowing CloudWatch to collect data and interact with the AWS Systems Manager, or SSM. One role manages configuration storage in SSM's parameter store, while another sends data to CloudWatch. Install the agent using the EC2 Systems Manager's run command. Select your EC2 instance, choose the Amazon CloudWatch agent package, and run the install action. If you enter the wrong package name, installation will fail, so accuracy is key. Configure the agent using the built-in wizard, specifying which metrics and logs to collect. Store the configuration in SSM's parameter store, then start the agent using Systems Manager. Now, your logs and metrics flow directly to CloudWatch. CloudWatch Logs centralizes data, making it easy to monitor, search, and respond to events across your AWS environment. Amazon CloudFront is Amazon Web Services' content delivery network designed to speed up the distribution of your content using a global network of edge locations. When you enable access logs, every user request to your CloudFront distribution is recorded for analysis. CloudFront access logs are generated at each edge location and are specific to each distribution. Logs for different distributions are kept separate, but all edge locations for a single distribution write to the same log file. These logs are delivered to Amazon Simple Storage Service, or Amazon S3. To enable logging, simply edit your CloudFront distribution settings, turn logging on, and select your S3 bucket for log storage. You can also add a log prefix or enable cookie logging, which records cookie data if your origin is not S3. You need full control permissions on the S3 bucket to enable logging. CloudFront uses your credentials to grant the AWS Data Feeds account access, allowing it to write logs. Log delivery to S3 can take from 1 to 24 hours. Web distributions log 26 fields per entry, including timestamp, edge location, requester IP, HTTP method, status code, and protocol. Real-time messaging protocol, or RTMP distributions, log 13 fields, such as event type and source IP. Virtual Private Cloud Flow Logs, or VPC flow logs, capture IP traffic information flowing between network interfaces in your virtual private cloud. This is essential for monitoring, troubleshooting, and securing your cloud environment, especially when managing hundreds of resources across multiple subnets and VPCs. Unlike Amazon Simple Storage Service access logs, VPC flow logs send data to Amazon CloudWatch logs, not to Amazon Simple Storage Service. However, there are limitations. You cannot monitor traffic from EC2 classic environments, and logs for peered VPCs are only available within the same account. Some traffic, like DHCP, Amazon DNS, and metadata service traffic, is not captured. You can create flow logs for a network interface, a subnet, or the entire VPC. During setup, select a filter for accepted, rejected, or all traffic. Choose an identity and access management role with the right permissions, and specify a CloudWatch log group. Remember, once created, flow logs cannot be modified. Delete and recreate if changes are needed. Each log entry includes details like version, account ID, interface ID, source and destination addresses, ports, protocol, packet and byte counts, timestamps, action, and log status. The action field is crucial for identifying accepted or rejected traffic. AWS Service Catalog is a powerful tool designed to simplify how organizations manage and provision IT resources. It lets IT admins pre-approve services like EC2 instances, databases, and software, making it easy for end users to deploy secure, compliant stacks without constant admin intervention. Within AWS Service Catalog, a product is any IT service you want to make available, from a single EC2 instance to a complex multi-tiered application. Products are created using AWS CloudFormation templates and can include detailed descriptions, versioning, and tags for tracking usage and costs. These products are grouped into portfolios, collections tailored for specific teams or roles, each with its own permissions and owner for accountability. Admins can apply constraints to products and portfolios, controlling who can launch resources, what configurations are allowed, and where deployments happen. For example, launch constraints use AWS Identity and Access Management or IAM roles to ensure only approved permissions are used. Template constraints help enforce compliance by limiting user options during provisioning. Service actions empower users to perform specific operational tasks, like database backups, without needing full access. AWS Service Catalog offers a free tier for up to 1,000 API calls per month, with minimal charges beyond that, making it cost-effective for most organizations. Managing software licenses in the cloud can be complex, especially when dealing with multiple vendors like Microsoft, SAP, Oracle, and IBM. Asset managers and auditors often struggle to keep track of licenses across both cloud and on-premises environments. AWS License Manager is designed to simplify this process. It supports tracking for any software where licensing is based on virtual cores or vCPUs, physical cores, sockets, or the number of machines. With AWS License Manager, you can create license configurations that include customizable rules tailored to your specific licensing agreements. These rules define how licenses are counted, set minimum and maximum thresholds for resources, and specify the total number of licenses available. You can set hard limits to block the launch of instances that would breach your license agreements, or soft limits that allow launches but send notifications. Rules can also specify which Amazon Elastic Compute Cloud, or EC2, tenancy types can consume a license, such as shared tenancy, dedicated instances, or dedicated hosts. AWS License Manager integrates with AWS Systems Manager and AWS organizations, enabling centralized monitoring across multiple AWS accounts and on-premises environments. It also supports Bring Your Own License from AWS Marketplace. AWS License Manager streamlines license management, helping you stay compliant and organized across all your environments. The AWS Health Dashboard is your central hub for monitoring the health of Amazon Web Services. It is divided into two main sections: events affecting everyone and events specific to your account's resources. Let's break down how each section helps you stay informed. First, you'll find Open and Recent Issues, which displays current problems across the AWS platform. If there are no major incidents, this section may be disabled. Below that, Service History provides a timeline of past issues, making it easy to investigate outages that happened over weekends or holidays. Switching to your account health, the dashboard correlates global AWS issues with your own resources. For example, if you run an EC2 instance, you might see scheduled events indicating upcoming maintenance. Simply stopping and restarting your instance moves it to new hardware, minimizing disruption. To avoid manually checking the dashboard, use EventBridge. EventBridge can monitor AWS health events, notify your operations team, and even trigger custom actions like creating support tickets, ensuring a fast response to any incident. With the AWS Health Dashboard and EventBridge, you can quickly identify, understand, and respond to issues, keeping your AWS environment running smoothly. Let's take a quick look at the AWS Management Console. The first step is always to get a broad overview of your environment. This means understanding which services you use, your current and past usage, and your overall expenses. To start analyzing costs, head to the Billing Dashboard. You can find it by typing Bill in the search bar or navigating through the menu. The Billing Dashboard is your main platform for tracking expenses and usage. The first thing to check is your bill from the previous month. Select the last month from the drop-down menu to see your total spending, tax details, and payment summaries. You can also download your bill as a CSV file or PDF. Focus on the most expensive services. For example, if Elastic Compute Cloud is your biggest cost driver, prioritize it in your analysis. Smaller expenses, like those for API Gateway or CloudFront, may not need deep investigation if their impact is minimal. Check which regions are being used. Some, like those in Asia, are more expensive than others, such as Northern Virginia. Ask why multiple regions are necessary and use this insight to guide further optimization. AWS Cost Explorer is a powerful built-in tool for managing your cloud finances on Amazon Web Services. It helps you analyze costs, spot trends, and identify major cost drivers in your environment, all at no extra charge for basic use. To access Cost Explorer, head to your AWS billing dashboard and launch the tool. You'll see a menu that lets you explore costs grouped by service, with a default 6-month overview displayed as a bar chart for easy comparison. You can adjust the time frame to view costs daily, monthly, or even forecast future spending. Use filters to focus on specific regions, services like EC2, or even drill down to instance types. The data table below the chart provides detailed breakdowns, which you can export for deeper analysis. Enable hourly and resource-level data for more granular insights, noting that this incurs a small fee. Choose between unblended and amortized cost views to match your accounting needs, especially if you use reserved instances or savings plans. Leverage filters to isolate untagged resources or analyze API operations for services like S3. With these features, AWS Cost Explorer empowers you to optimize spending and make informed financial decisions in the cloud. The AWS Cost and Usage Report, or CUR, is the most essential tool for capturing your AWS billing data. This detailed CSV file records every aspect of your cost and usage data across all AWS resources, providing historical, by-the-hour insights that help you spot trends and make informed decisions. To start using the CUR, head to the AWS Management Console. On the billing dashboard, find the Cost and Usage Report option in the left menu. By default, it is disabled, so you will need to enable it and create a new report. Give your report a name and be sure to include resource IDs for unique tracking. Next, choose an Amazon S3 bucket to store your CUR files. You can select an existing bucket or create a new one, set a path, and pick your preferred time granularity. Remember, more granular data means larger files. You can also decide whether to create new report versions or overwrite existing ones. CUR files can be exported for use with Amazon Athena, Redshift, or QuickSight. Athena uses Parquet files for serverless SQL analysis, while Redshift and QuickSight use CSV files for big data queries and visual dashboards. Expect minimal S3 storage costs for your CUR data. Before cloud computing, companies had predictable costs thanks to fixed procurement processes. Contracts were signed up front, and expenses were easy to track. But with the shift to the cloud, costs have become variable. While this brings speed and flexibility, it also makes it harder to understand and control spending. Now, application and finance teams must collaborate more closely to manage budgets effectively. To tackle these challenges, teams need to track usage, set budgets, and receive alerts when spending exceeds limits. AWS Budgets is designed for exactly this. It lets you monitor your Amazon Web Services, or AWS, usage and costs, set custom budgets, and get notified if you approach or exceed your budget. This helps both business leaders and engineering managers make informed decisions. With AWS Budgets, you start by defining what you want to track, such as cost, service usage, or coverage for savings plans and reserved instances. Next, you set your budget amount and decide which projects or services it applies to. For example, you might set a $100 monthly budget for all services. You can configure alerts at thresholds like 80% of your budget and choose notifications via email, simple notification service, or AWS chatbot. AWS budgets can even automate actions such as changing permissions or stopping instances and generate reports for leadership to review. Understanding where your cloud budget goes is crucial. In Amazon Web Services, or AWS, cost allocation strategies help you track spending by resource and service. The key to this visibility? Tagging every resource in your cloud environment. Tags in AWS are simple key and value pairs attached to resources. For example, you might tag resources with environment, production, or service backend. These tags let you instantly see which resources belong to which business unit, project, or application. AWS offers the Cost and Usage Report, also known as CUR. This report tracks your monthly costs and usage, breaking down data by product, usage type, and operation. CUR files are stored in Amazon Simple Storage Service, or S3, and can be updated up to 3 times daily. Start tagging resources from the very beginning. Use clear, consistent tags that match your business needs. Avoid retroactively tagging resources, as it can be frustrating and confusing. Consider policies that require tags before deploying new resources. A well-planned tagging strategy makes cost allocation simple and insightful. Use AWS tools like Cost Explorer and CUR for detailed analysis. Remember, effective tagging leads to better decisions and greater control over your AWS spending.
Tagging your resources is essential for any organization looking to manage costs and streamline operations. By applying the right tags, you can easily track, allocate, and optimize your resources across different departments and projects. Some of the most widely used tags include cost center or business unit tags, which help allocate resource costs accurately. Service or workload name tags identify which service a resource belongs to, while resource owner tags clarify responsibility. Simple resource name tags make resources easier to recognize, and environment tags distinguish between development, testing, and production environments. Check your cloud provider for pre-generated tags like those offered by Amazon Web Services to save time. Start by aligning your tags with your overall cost allocation strategy. Tag every resource to avoid gaps in your data and ensure each tag serves a clear purpose. Limit the number of tags to avoid redundancy and keep things manageable. Consistency is crucial, so use clear, descriptive naming conventions for all tags. Automate tag management with tools like the Amazon Web Services Tag Editor to save time and enforce policies that prevent untagged resources. Regularly audit and maintain your tags, involving your entire team to ensure ongoing accuracy and improvement. AWS cost allocation tags are essential tools for tracking and managing your cloud spending. These special tags help you organize costs by project, department, or any custom category, making it easier to visualize and allocate expenses across your organization. To make the most of cost allocation tags, you need to activate them in the AWS billing section. Once activated, AWS detects all tag keys used in your account and suggests them for activation. Only active tags will appear in Cost Explorer charts and reports. For example, tags like Cost Center and Name can be enabled, while inactive tags are linked to resources no longer in use. Without activating these tags, you will not be able to filter or analyze costs by tag in Cost Explorer or other AWS services. There are 2 main types of cost allocation tags: user-defined and AWS-generated. User-defined tags are custom tags you create, while AWS-generated tags, such as created by, are automatically applied to resources for cost tracking. Both types are visible only in the AWS Billing and Cost Management console. To enable AWS-generated cost allocation tags, log into your master account as an IAM user with the right permissions. In the billing console, select Cost Allocation Tags from the menu, then click Activate to enable the tags. AWS Systems Manager is a suite of fully managed services designed to automate configuration and ongoing management of your systems at scale. Whether your instances run on Amazon EC2, in your own data center, or on other cloud platforms, Systems Manager delivers secure, reliable operations. With Systems Manager, you can select which instances to manage and define the tasks you want to perform. Schedule modifications using maintenance windows, create and update system images, collect software inventory, apply patches, and configure both Linux and Windows operating systems. All of this can be done from a single console or through the command line interface, streamlining your workflow and reducing complexity. Forget about juggling multiple tools for different platforms. Systems Manager eliminates the need for secure shell keys, remote desktop ports, or Bastion host to connect to your instances. Its cloud-native design supports agility and elasticity, letting you manage one or thousands of instances, regardless of workload duration. Systems Manager integrates seamlessly with other AWS management tools, including Identity and Access Management for access control, CloudTrail for auditing, and CloudWatch events for automation, all without complex licensing. AWS Systems Manager empowers you to automate, maintain, and manage your entire infrastructure with complete visibility and control wherever your systems reside. AWS Systems Manager is designed to fit seamlessly into your existing Amazon Web Services configuration and management toolset. It offers a comprehensive solution for managing your cloud resources, making it easier to oversee operations across your entire environment. One of the standout features is the Systems Manager Explorer, a customizable operations dashboard. Explorer delivers a unified view of your operational data and work items, spanning all your accounts and regions. You can tailor the dashboard to your needs using drag-and-drop functionality and drill down into specific detail to prioritize tasks. This flexibility helps you stay organized and focused on what matters most. Explorer also enables you to take action quickly by using automated runbooks when necessary. Systems Manager integrates smoothly with your Amazon CloudWatch dashboards and your personal health dashboard, ensuring you have all the information you need in one place. With these capabilities, AWS Systems Manager empowers you to provision and operate your resources efficiently at scale, streamlining cloud management for your organization. AWS Systems Manager offers over 20 features and integrations, providing a unified dashboard to manage the lifecycle of your cloud instances. It helps you organize, monitor, and act on your AWS resources efficiently and securely. Some of the standout features include Fleet Manager, Session Manager, Run Command, Parameter Store, Patch Manager, and State Manager. These tools let you manage inventory, patch assets, run commands, and securely connect to Amazon Elastic Compute Cloud, or EC2, instances in private subnets. Most features use Systems Manager documents to define operations and maintenance windows to schedule them. You can select which instances to manage in 3 ways: manually, by choosing each instance, by using instance tags, where you specify tag key value pairs, or by leveraging resource groups, which let you operate on logical collections of resources. Resource groups are built using common tags and can represent development tiers, departments, or projects. They can also be based on CloudFormation stacks, mirroring the stack's logical structure for streamlined management. Tagging your resources is essential. With the Tag Editor and Tag Policy Editor, you can organize, enforce, and bulk edit tags, making resource management and visibility much easier across your AWS environments.
AWS Systems Manager is a powerful service that helps you manage your cloud and on-premises infrastructure. To use its features, every server or virtual machine must become a managed instance, which means it can communicate with Systems Manager. The key to this communication is the Systems Manager Agent, or SSM agent. This software must be installed and configured on each instance. It comes pre-installed on Amazon Linux and AWS Windows images, and is available for other platforms like Ubuntu, Red Hat Enterprise Linux, SUSE, and CentOS. The SSM agent is open source and can even be installed on physical servers or virtual machines outside AWS. Each managed instance needs an Identity and Access Management or IAM role. AWS provides predefined policies such as the Amazon EC2 role for SSM to simplify setup. For non-EC2 servers, you can use hybrid activations to register and centrally manage them alongside your EC2 instances. Once configured, all managed instances appear in the Fleet Manager console. Here you can view details like instance ID, operating system, IP address, and SSM agent version. Session Manager lets you securely connect to instances without opening inbound ports or managing keys. It uses Transport Layer Security version 1.2, supports full session logging, and integrates with AWS security tools for auditing and access control. Once you have configured your managed instance with the Systems Manager agent and assigned the appropriate access role, you can access the Systems Manager console. Under the Node Management section, you will find the Fleet Manager feature, designed to simplify instance management. Fleet Manager displays all your managed instances in one place, providing visibility into key details such as instance ID, platform type, instance type, operating system name, IP address, and the version of the Systems Manager agent. This centralized view makes it much easier to monitor and manage your entire fleet. Within the same Node Management section, you will also see the Session Manager feature. Session Manager is a fully managed capability that allows you to connect to any managed instance using an interactive browser-based shell. It supports Linux, Windows, and macOS instances, making it a versatile tool for administrators. Session Manager does not require open inbound ports, bastion hosts, or the management of SSH keys. You also do not need SSH or remote desktop clients. All communication is secure, and every command and output can be tracked and dispatched to CloudTrail, CloudWatch, or Amazon S3 for auditing. AWS Systems Manager Run Command is a powerful tool that lets you execute commands across one or more of your managed instances. Whether you need to automate routine tasks or perform complex administrative actions, Run Command streamlines the process, making management at scale much simpler. To use Run Command, you start by selecting a Systems Manager document. These documents, written in JSON or YAML, define the actions to be performed on your instances. You can use pre-built documents like the popular AWS Run Shell script or create your own. Documents are reusable and can accept parameters, allowing you to tailor commands for different scenarios. When executing a command, you specify both the document and the target instances. For large environments, Run Command offers rate control. This feature lets you set concurrency, determining how many instances receive the command simultaneously, and an error threshold, which stops execution if failures exceed your set limit. Run Command provides flexible output options. You can direct command results to an Amazon S3 bucket or Amazon CloudWatch logs. Additionally, you can configure notifications through Amazon's Simple Notification Service, or SNS, to stay updated on command status and results.
AWS Systems Manager Parameter Store is a centralized solution for managing your application configuration and secrets. Whether you need to store plain text data like database connections or sensitive information such as passwords, Parameter Store provides a secure and organized way to handle it all. One of the standout features is its integration with the AWS Key Management Service, or KMS, which allows you to automatically encrypt sensitive values. This means your secrets are protected without extra effort. Parameter Store also enhances security by separating configuration data from your code, and it offers integrated audit capabilities through AWS CloudTrail. This lets you track who accessed or changed your parameters, adding an extra layer of accountability. Parameters can be tagged and organized into hierarchies, making it easy to manage different environments like development, quality assurance, and production. You can track changes using parameter versions, set up notifications for updates, and even create custom validation routines using AWS Lambda functions. Parameter Store is not limited to AWS Systems Manager. You can reference parameters in services like Amazon Elastic Container Service, AWS Lambda, CloudFormation, Code Deploy, Code Pipeline, and your own applications. Simply create a parameter, specify its type and value, and reference it wherever needed. In Amazon Web Services, or AWS, maintenance windows are a powerful way to schedule potentially disruptive administration tasks. Instead of running updates or patches manually, you can automate these actions to occur during a specific, predefined period, minimizing impact on your workloads. A maintenance window is an independent resource in AWS. To set one up, you define a schedule that specifies exactly when tasks can run. You can choose a start and end time, or use cron or rate expressions for recurring schedules. You also set the duration in hours, ensuring tasks only run within your chosen window. Once the window is created, you register targets by name, using instance tags, resource groups, or by selecting instances manually. With your maintenance window in place, you can register tasks to run. These might include run command documents, automation document tasks, Lambda function tasks, or step functions tasks. You can also set limits for how many tasks run simultaneously and the allowable error rate. AWS keeps a history of all executed tasks for easy review. Maintenance windows help you avoid operational downtime by grouping disruptive tasks into controlled periods. This flexibility ensures your systems stay updated and secure without unexpected interruptions. Systems Manager is a suite of services designed to help you manage your computing instances securely and efficiently, no matter how many you have. It brings together all your operational data, giving you a unified view for performance and compliance. To take full advantage of Systems Manager, your machines need to become managed instances. A managed instance is any machine that can communicate with Systems Manager and meets a few essential requirements. This setup allows you to securely connect, collect inventory, and automate tasks. First, you must install and configure the Systems Manager agent on each machine. This agent processes tasks you specify, such as running commands or collecting data. Second, each instance needs a role with the right permissions. You can use the Amazon EC2 role for Systems Manager or the Amazon SSM Managed Instance Core policy to define these permissions. Third, your instance must have network access to the public Systems Manager endpoint. This is achieved through an internet gateway for public subnets or a virtual private cloud endpoint for private subnets. With these 3 steps, your instances are ready for Systems Manager, enabling secure, centralized management across your entire fleet.
Systems Manager documents are a key part of how AWS Systems Manager operates. These documents define the steps and parameters for actions you want to perform, and they are written in either JSON or YAML. They act as independent resources within the Systems Manager ecosystem. Systems Manager supports over half a dozen document types, but the most common is the command document. Command documents are essential for the run command feature, which lets you specify exactly what actions to execute on your managed instances. They are also used by the state manager to apply configurations and by maintenance windows to schedule tasks. With a command document, you can run shell scripts, configure CloudWatch, set up Docker, or perform other administrative tasks on your instances. These documents are versatile and can be tailored to fit a wide range of operational needs, making them a powerful tool for automation. There are more than 100 pre-configured Systems Manager documents available. You can use them as they are or modify them to suit your requirements. Common examples include AWS Run Shell scripts for Linux and AWS Run PowerShell script for Windows. AWS Systems Manager is a powerful tool for managing your cloud infrastructure. Let us explore some of its key features that help you control, automate, and secure your instances. With Fleet Manager, you get a centralized view of all your managed instances. This feature provides detailed visibility into each instance, making it easy to monitor and manage your entire fleet from one console. Session Manager allows you to connect securely to any managed instance using an interactive browser shell. There is no need for open inbound ports, bastion hosts, or SSH keys. All sessions are tracked for auditing and compliance, ensuring secure and accountable access. Run Command lets you execute commands on one or multiple instances at once. You define the actions using command documents, control how many instances are updated simultaneously, and set error thresholds to pause execution if issues arise. Parameter Store separates configuration data from code. It securely stores plain text data and secrets, integrates with the AWS Key Management Service, and supports versioning, notifications, and validation routines using AWS Lambda functions. Maintenance windows let you schedule tasks like patching or software updates during predefined periods, minimizing downtime and ensuring your applications remain available while critical maintenance is performed. Managing patches across your servers can be complex, but Patch Manager, a feature of AWS Systems Manager, streamlines the process. It automates patching for both security and reliability, keeping your managed instances up to date and secure. Patch Manager supports a range of operating systems, including Amazon Linux, Ubuntu Server, and Windows Server. You can scan your managed instances to identify missing patches or let Patch Manager automatically install them. It also generates patch compliance reports, so you always know where your systems stand. Patches are defined using patch baselines. AWS provides predefined baselines for each supported operating system, but you can create custom baselines for more control. Organize your patching strategy with patch groups using a case-sensitive tag key, patch group. Assign values like web servers or app servers to target specific environments or application tiers. Patch Manager integrates with AWS CloudTrail, Amazon EventBridge, Amazon S3, AWS Config, and AWS Identity and Access Management. This allows you to gather patch data and send it to other AWS services, supporting compliance and audit requirements. Schedule patches during maintenance windows to minimize disruption. Use Systems Manager documents like AWS Run Patch Baseline and AWS Configure Windows Update for flexible, automated patching across your fleet. State Manager is a secure and scalable configuration management feature within Systems Manager. It gives you control over how configurations are applied across your managed instances, whether you are adjusting firewall settings, shutting down unused ports, or disabling unnecessary services. With State Manager, you define policies using automation documents, including several predefined options for common scenarios. These policies are assigned through an association, which specifies what needs to be done, the target instances, and a schedule for when changes occur. For example, you can configure network settings or automatically install software modules at startup, ensuring your desired state is always maintained. State Manager supports configuration scripts in Shell, Ruby, and Python, and works seamlessly with existing tools like Ansible, Salt, or PowerShell. It can identify and repair compliant and non-compliant machines across multiple accounts. Integration with Amazon EventBridge enables event-driven automation, while outputs can be sent to CloudWatch logs or Amazon S3 for monitoring. All API interactions are logged in CloudTrail, providing a complete audit trail. Native integration with identity and access management lets you control who can access State Manager and run configuration tasks, ensuring enterprise-wide compliance and security. AWS X-Ray is a service that helps developers analyze and debug distributed applications, especially those built with microservices. With X-Ray, you can see how your application and its underlying services are performing, making it easier to identify and troubleshoot performance issues and errors. X-Ray provides an end-to-end view of requests as they travel through your application, mapping out all the underlying components. You can use it to review request behavior, discover application issues, and improve performance. X-Ray works seamlessly with other AWS services like Amazon EC2, AWS Lambda, and AWS Elastic Beanstalk, and supports popular programming languages such as Java, Node.js, and .NET. X-Ray traces user requests, aggregates data from different services, and lets you visualize relationships and latency between components. You can even tag and filter trace data to diagnose issues faster. To get started, simply launch a sample application from the X-Ray console using a provided CloudFormation template. Within minutes, you'll see real-time request data and performance insights. Amazon Athena is now included in the AWS Certified Developer Associate exam. So let's take a quick look at what this powerful service offers and how it can help you analyze your data. Amazon Athena is a fully managed serverless service that lets you interactively query data stored in Amazon S3 data lakes, as well as other sources like data warehouses and big data repositories. You use standard structured query language, or SQL, so there's no need to learn a new language. Athena is designed to handle datasets up to petabytes in size, and you only pay for the queries you run. Athena uses Data Definition Language, or DDL, to define tables and supports a variety of file formats, including CSV, JSON, and Parquet. You can specify partition keys to efficiently query large datasets by any column. Athena integrates with services like Elastic MapReduce, or EMR, AWS Glue, QuickSight, and Redshift Spectrum, making it easy to build analytics pipelines. It also supports querying data in S3 compressed, helping reduce storage costs. You can interact with Athena using AWS Software Development Kits, the AWS API, or ODBC and JDBC drivers, making it accessible for developers. That's a quick introduction to Amazon Athena. Good luck on your certification journey. Amazon Kinesis Data Firehose is a fully managed service designed to simplify the process of delivering streaming data to various destinations. It handles all the infrastructure, storage, and networking, so you do not need to worry about provisioning or maintaining hardware or software. Kinesis Data Firehose can collect, transform, and load large datasets to destinations like Amazon S3, DynamoDB, Amazon Redshift, OpenSearch, Splunk, and more. It automatically scales to handle your data volume and replicates data across 3 facilities within a region for durability. You can send data to Firehose from Kinesis data streams or directly from any application, making it flexible for different use cases. Firehose buffers incoming data based on size or time before delivering it. For example, buffer sizes range from 1 megabyte to 128 megabytes for Amazon S3, and buffer intervals can be set from 60 to 900 seconds. Firehose does not use shards and is fully automated for scalability, ensuring seamless data delivery. Firehose can compress and encrypt data and optionally back up transformed data to another Amazon S3 bucket. The Kinesis agent, a Java application, can be installed on Linux or Windows systems to collect and send data, making integration straightforward for web, log, or database servers. Amazon OpenSearch Service is a fully managed search service from Amazon Web Services, or AWS. It is the successor to Amazon Elasticsearch Service and lets you deploy OpenSearch clusters with ease. OpenSearch itself is an open-source search, analytics, and visualization suite created by Amazon, based on Elasticsearch and Kibana. If you are familiar with the ELK stack, which stands for Elasticsearch, Logstash, and Kibana, you will find OpenSearch very approachable. With OpenSearch, you can index and search large collections of data, making it ideal for website search, real-time application monitoring, and interactive log analytics. OpenSearch supports both Elasticsearch and OpenSearch application programming interfaces, or APIs, so adding custom search features to your applications is straightforward. It also integrates with visualization tools like Kibana and OpenSearch dashboards. For high availability, you can deploy OpenSearch clusters across 2 or 3 availability zones. OpenSearch can ingest streaming data from Amazon CloudWatch logs, Kinesis Data Firehose, and other AWS services such as S3 and DynamoDB. OpenSearch offers tiered storage, including hot, ultra-warm, and cold storage tiers, providing cost-effective options for both frequently updated and archived data. There is also Amazon OpenSearch Serverless, which lets you run OpenSearch without managing clusters. You pay only for the resources you use, with data durability similar to Amazon S3. Amazon OpenSearch Service is now included in the AWS Certified Developer Associate and AWS Certified DevOps Engineer Professional exams. Good luck on your certification journey. Amazon Managed Grafana is a fully managed service from Amazon Web Services, or AWS, built on the open-source Grafana analytics and visualization platform. With this service, you can harness Grafana's powerful data visualization and operational dashboarding capabilities without the hassle of provisioning infrastructure or installing software. With Amazon Managed Grafana, you can create workspaces, which are logically isolated Grafana servers. Each workspace can connect to a variety of data sources, including Amazon CloudWatch, AWS X-Ray, the Amazon Managed Service for Prometheus, and Amazon TimeStream. You can create multiple workspaces per account within the same AWS region, making it easy to organize and manage your monitoring environments. The service also integrates with AWS organizations, giving you a comprehensive view across your AWS accounts and resources within your organizational units.
access management is streamlined through AWS Single Sign-On, or SAML. You can assign users administrator, editor, or viewer privileges. Administrators manage data sources, users, teams, folders, and dashboards. Editors can work with dashboards and alerts, while viewers have read-only access to assigned dashboards. If you need more advanced features, you can upgrade your workspace to Grafana Enterprise. This unlocks additional third-party plugins, as well as support and training from Grafana Labs.
Amazon Managed Service for Prometheus is a powerful, serverless solution designed to monitor container metrics at scale. It is now included in the AWS Certified DevOps Engineer Professional exam, making it essential knowledge for candidates. This service is fully compatible with Prometheus, the popular open-source systems monitoring and alerting toolkit. With Amazon Managed Service for Prometheus, you do not need to provision or manage any infrastructure. It automatically scales as your containerized workloads grow or shrink, ensuring seamless performance. The service also provides multi-availability zone deployments for high availability. Any data ingested into a Prometheus workspace is automatically replicated across 3 availability zones within an AWS region, offering robust data durability and resilience. Amazon Managed Service for Prometheus can monitor applications running on Amazon Elastic Container Service, Amazon Elastic Kubernetes Service, AWS Fargate, and even self-managed Kubernetes clusters on premises or in other clouds. It supports the Prometheus Query Language, or PromQL, so you can filter and aggregate metrics without writing code. Integration with Amazon Managed Grafana enables advanced monitoring, alerting, and dashboards. This overview highlights the key benefits of Amazon Managed Service for Prometheus. Good luck as you prepare for your AWS certification journey. That's all in this video. Let's see you in the next part. If you're not already subscribed, please subscribe to our YouTube channel. Thanks. For all the latest real exam question and answers and more content, please visit our website, www.shapingpixel.com.